Assalamu alaikum and very good morning dear students. Today we are starting a last video of this chapter. The chapter is operation on sets and today's topics are distributive property of sets and De Morgan's laws. Dear students, please open your mathematics books, new countdown book 8. By the end of this lesson, you should be able to understand, prove and implement distributive property of union over intersection, understand, prove and implement distributive property of intersection over union, and understand and prove De Morgan's laws. Properties of sets. In our previous lesson, we learned some of the properties. Today we are learning distributive property of union over intersection. It states that A union in the bracket B intersection C is equals to in bracket A union B intersection in bracket A union C. Now set A is 1, 2, 3, 4, 5, 6, 7 and 8 and set B is 2, 3, 4, 5 and 6 and elements of set C are 1, 3, 5 and 7. Now to prove that A union bracket B intersection C is equals to A union B intersection A union C, we will see A union B intersection C. First we will solve B intersection C because yes, it is inside the bracket. So B intersection C is the elements are 3 and 5 because in set B and set C only 3 and 5 are common. So B intersection C is equals to 3 and 5. Now we will make its union with A. So it is 1, 2, 3, 4, 5, 6, 7 and 8 and when we will make its union, the set we have is 1, 2, 3, 4, 5, 6, 7 and 8. Now here, first we will find A union B. So it is 1, 2, 3, 4, 5, 6, 7, 8 and when A union C, it is also 1, 2, 3, 4, 5, 6, 7 and 8. Now when we will make its intersection, because all the elements are common here, so all the elements are part of a obtained set. So left hand side is equals to right hand side. So the distributive property of union over intersection is proved. Now we will show it in Venn diagram. Now here this is set A and this is set B intersection C and the members of B intersection C are 3 and 5. So when we will make its union with A, we will have 1, 2, 3, 4, 5, 6, 7 and 8. So this shaded part is showing A union bracket B intersection C. And here this circle is showing A union B and this circle is showing A union C. And because all the elements of A union B and A union C are common, so all of these are part of this intersection area. So now all these elements which are lying in shaded part is the answer. So it means all the elements here 1, 2, 3, 4, 5, 6, 7, 8 are same as this set. So these are equals to this. Hence the property is proved in Venn diagram also. Now distributive property of intersection over union. It states that A intersection bracket B union C is equals to A union B bracket close union A intersection C intersections B union A intersection C. Now set A B, C, D, E, F and G, set B is B, C, E and G and set C is A, D and F. So when we will find A intersection B union C, first we will make union of B and C which is A, B, C, D, E, F, G. Then we will find its intersection with A. So A, B, C, D, E, F, G are common with these A, B, C, D, E, F, G. So the intersection set is A, B, C, D, E, F, G. Now here intersection B, the common elements of A and B are B, C, E and G. And here intersection C, so the common elements are A, D and F. And when we will make their union, we will get A, B, C, D, E, F, G, which is same as left hand side set. So left hand side is equals to right hand side. So it is proved that distributive property of intersection over union is correct or proven. Now we will represent this in Venn diagram. Now look here, this is set A and this is set B union C, and all the elements are common in both the sets. So all the elements are lying in central area or in the area where we are representing intersection elements. Here A intersection B, so it is this set, and A intersection C is this set, and when we will make their union, all the elements are lying under shaded area. So from A till G, all the elements of both the sets are same, so it means that these are same. Okay, now I want to reinforce some of the things. Now let's see. Yes, what is universal set? Who can tell me? Very good. Exactly. Most of you remember that universal set is a set which contains all the sets under consideration. Suppose, I think it will be more clear to you people when we will consider an example. Like set A has elements April and August, and set B has elements January, June and July, and the universal set is months of the year. So all the members which could be part of any of the set which are related to months of the year, and their universal set will be this. Okay, so I hope that you remember what universal set was and why I am discussing this. Yes, most of you know this, smart people, that we will taking this in use in our next topic. Yes, now another thing, complement set. Now who remember this? Yes, good. So the complement set, all the elements which are members of universal set except the elements of set A are called complement of set A and denoted by A dash. I will make it easier for you that if we have to find complement of any set, so we will write it in this form, A dash, and A dash is equals to universal set minus A. So any other set, suppose we want to find B dash or complement of B, we will do U minus B. So it is just, if we have to find complement of any set, we will minus that set from universal set. Now, De Morgan's laws. Augustus De Morgan was a British mathematician of 18th century. He developed two laws used in sets. The first law is A union B complement is equals to A complement under intersection B complement. And second law is A intersection B complement is equals to A complement union B complement. Now we will see that really are these the laws, so we have to prove these. We will take help of some examples, like to prove A union B complement equals to A complement intersection B complement, we are taking a universal set which has elements 2, 4, 6, 10, 12 and 14 in it. Now set A has elements 2, 6, 10 and 12, and set B has elements 6, 10, 12 and 14 in it. Now A union B, so first we will find A union B. 2, 6, 10, 12 and 14 are the members of A union B. Let's confirm from here. 2 is part of A, then 6, then 10 and 12, and when we look at set B, 6 is here, 10 is here, 12 and then 14. It means this set is A union B. And when we have to find its complement, we will minus it from U. So U is 2, 4, 6, 10, 12 and 14. So what is extra in universal set? Yes, only 4, because all other members which are part of A union B can be cancelled from this and only 4 is left. Let's check. 2 is cancelled by 2, 6 minus 6, 10 and 10, 12 and 12, 14 and 14. So all these are minus. So only 4 is left. Now we will come to right side. Here we have to prove that A complement and B complement we have to find at their intersection. So First we will find A complement. U minus A, then we will get A complement. So let's see here. This is U and this is A. So when we will minus, what is extra in U? 2 is here, 2 is here, 4 is here. Yes, so 4 we will write here because 4 is not part of A. Then 6 and 6, 10 and 10, 12 are matching, and then 14 is left. So it means A complement has elements 4 and 14. U minus A has 4 and 14 in it. Now B complement, so we will do universal set minus B. So it is universal set. When we will minus B from it, we will get 2 and 4, because see, this universal set has 2, B doesn't have, then 4, that is not even here, then 6, 10, 12 and 14 are here also. So we will not write, only 2 and 4 are the members of B complement. When we will find intersection of 4 and 14 and 2 and 4, so only 4 is the member of it. So it means left hand side is equals to right hand side. So Morgan's first law is proved. Did you see that very different sets we found, but they get the same answers? Smart thing. Okay, now second law of Morgan is A intersection B complement is equals to A complement union B complement. Now we will prove. Universal set is 2, 4, 6, 10, 12 and 14 in it. A has 2, 6, 10 and 12 in it, and B 6, 10, 12 and 14. When we find A intersection B, and then we will make its complement, we will minus it from universal set. So universal set is here 2, 4, 6, 10, 12 and 14. Then A intersection B, A intersection B. So which elements are matching here or common here? Yes, it is 6, 10 and 12. So we have written 6, 10 and 12 here. So now when we will minus, we will get 2, 4 and 14. So because 2, 4 and 14 are not part of A intersection B. So to get complement of A intersection B, we will get 2, 4 and 14 in it. Now here right side we have to find complement of A and complement of B, and then we will make their union. So complement of A is universal set minus A. Universal set minus A has 4 and 14 in it, and then universal set minus B has 2 and 4 in it, and when we will make their union, we have 2, 4 and 14 in it. Same elements of left hand side and right hand side. It means Morgan's second law is also proved. I feel you like these laws. These are very interesting and surprising even. Now we will summarize what we learned today. First we learned distributive property of union over intersection. Then we did distributive property of intersection over union. Then we did De Morgan's first law, and then De Morgan's second law. I hope you enjoyed today's lesson and you can easily implement your learning in your written assignments. Your written assignments are Task 1, question number 9, exercise 1, page 19 of new countdown 8. Task 2 is question number 10, exercise 1, page 19 of new countdown 8. Task 3 is question number 11 and 12, exercise 1, page 19 of new countdown 8. And your last task is question number 13, exercise 1, page 19 of new countdown 8. And now our chapter is finished. I hope you enjoyed this topic. Allah Hafiz. Keep practicing.